Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem main cast to add for palindrome, which is a hard level problem. Okay. And it is one of the application of KMP algorithm that we have learned just yesterday. Okay. So if you don't know KMP algorithm, then this problem will never hit your head, right? Like if you try to apply any brute force approach or any recursive approach, you will find bit trivial. But if you know KMP algorithm, this might hit you. So let's see the problem description first. The problem says, given a string S, the task is to find the minimum characters to be added at the front to make the string palindrome. There's a note point here saying a palindrome string is a sequence of characters that reads the same forward and backward. So we have been given a string, need to find the minimum characters that we need to add at the front of the string to make the string palindrome. That is, the string can either be a palindrome or not, but if it is not a palindrome, how many minimum characters we need to add to make it palindrome? That is the question. And here they have given the definition of palindrome. That is, a palindromic string is a sequence of characters which will be same if we read the same from forward or backward. Okay. So the problem description is clear. Now let's see the examples. So in the example 1, the input is ABC and the output is 2. The explanation says add BC at the front of the string to make it palindrome, right? So ABC is not a palindrome. So what are missing to make this palindrome? C and B, right? So if we prepend C and B in front of ABC, then it becomes a palindrome, right? So we added two characters. That's why the output is 2. Now similarly, in the second example, the string is AACE CAA8 and the output is 2. The explanation says add 2s at the front of the string to make it palindrome. So this is the whole string. In that we have prepended both A and A. With this, the whole string became a palindrome. And since we added two characters, the output is 2. Simple. So we have understood both of the examples too well, right? Now let's see how we can use KMP algorithm for this. Now before moving to example Rairan, if you guys don't know about KMP algorithm, then I have made a detailed explanation video on how KMP algorithm works and try to explain it in such a way that it feels almost intuitive. Although it is not that intuitive, but I have explained it thoroughly. So if you know KMP algorithm, well and good. But if you don't know, I want you guys to watch this video and get the knowledge of KMP algorithm, because without this you can't understand what I am explaining below. Okay, so this is one of the prerequisite, and it is not important that you need to understand whole video. In the whole video I have break down KMP algorithm in two steps, step number 1 and step number 2. So try to watch the KMP algorithm from start till step number 1. Step number 2 was also one of the application of KMP algorithm, but here just with step number 1 we can solve our problem. In step number 1 we find longest prefix suffix array, which is useful in this problem. So again, if you know the KMP algorithm, well and good, but if you don't, just give it a shot for this video. Okay. So keeping in mind that you know KMP algorithm well, now let's try run the examples. Let's suppose we have two strings. In the first string, we have ABC, and in the second string, we have ABA. Now this string is not a palindrome, but this string is a palindrome, right? So to make this string as palindrome, in the worst case scenario, what we can do? We need to prepend all the characters in reverse order, right? That means if I take this string ABC, I need to reverse this string. So it becomes CAB, right? Now I need to append this string to this string, right? So let me append it. Now this string is a palindrome string, right? Because if we read from both forwards or backwards, it is a palindrome. Now in the second example, ABA itself is a palindrome, right? But still, let's do the operation where we take the original string, reverse it and prepend it, right? So even after prepending the reverse string, the whole string is still a palindrome, right? Because the parent string was already a palindrome. Now after we generate both of this, we need to find LPS array for each individual. Now why do we use LPS here? That is the main doubt, right? So let's take an example. We have a string where we have a pattern matched and we have some extra characters and again a pattern match, right? So through LPS, we can find the longest prefix, which is also a suffix, right? Now for the string which is already palindrome and we performed an operation here, right? What is the longest prefix suffix for this? It is ABA, right? Because ABA is equals to ABA and the length of longest prefix suffix is 3, right? So what does this 3 signify? That the length of the original string is 3 and the length of longest prefix-suffix is 3. That means that string is already a palindrome. Now, if we perform the same operation for ABC, the generated string is CAB-ABC. Now here, the longest prefix-suffix is just C, right, which is of length 1. So if we see the difference of the length of the original string, which is 3, and the length of longest prefix-suffix, which is just 1, we need to have 2 extra characters, right? Now, what does the 2 represent? The 2 represents that there are 2 characters in the strings which are not contributed in finding the longest prefix-suffix, right? Now, if it was a palindrome, that is the string here is BA. So, the longest prefix-suffix would have been of length 3 that we have found here, right? So, this way, through longest prefix-suffix array, we can find how many extra characters we need to add, right? So, let's take the LPS array for both of the examples. So here I have generated LPS array for both of the arrays to save the time. So again, if you don't know how to generate this array, please watch my video till step number 1. You will get the idea. Okay. So this LPA array itself says that at index number 5, it is the only longest prefix suffix character here. And here at index number 5, the length is 3. So the whole ABA is a longest prefix suffix, right? Now in both of the arrays, the last element says what is the longest prefix which is a suffix, which is nothing but which characters have been matched properly, right? So in this case, only C has been matched, and in this case, both ABA has matched. So if we take the difference of the original length of the string and the last element of the LPS array, we'll get the difference of how many extra characters were needed. So the length of the ABC here is 3, right? So if we take the difference of 3 with the last element, which is 1, we'll get 2. Now this 2 signifies that we need to add 2 extra characters here. And what could be those 2 extra characters? CB. Simple. And similarly, the length of this string is 3, right? So if we take the difference of this and this, which is nothing but 3 minus 3, which equals to 0. That means there is no need of adding any extra characters, right? Because the string itself is a palindrome. Okay. So this way, using LPS array, we can easily solve this problem. But if you don't know about LPS, this is not at all an intuitive problem, right? So we have understood both of the diagrams. Now let's see the code. So here's the code in C++, although the logic remains same. So the function name is minCap and the string has been provided and we need to return the minimum length in integer form. So firstly, I have stored S in temp variable, reversed it and created a new string str where I have appended both original string and the reverse string. Okay. But now after creating the string, I have taken its length. Okay. Now this is the whole logic that we are doing in LPS, that we have taken the LPS array and we have initialized the length. We are running a loop while I is less than n, checking the pattern, expanding the window, but if it is not, shrinking the window. So if you want to know it detailedly, you watch my video, okay? So after we generate this LPS array inside this while loop, what we can do? We need to take the difference of the original string that is provided, s, right? So s dot size minus the last element of the LPS array, which is LPS of n minus 1. So this difference will tell us how many minimum characters that we need to add. Now, what will be the time complexity for this approach? Here, we are using a reverse operation, which is of O of n, okay? And here, we are generating the LPS of string str, where str is s plus temp, right? So, this while loop will run for n plus n times, right? So, the overall time complexity is O of 2n, which can be approximated to O of n. Simple. Now, what will be the space complexity? Here, we have taken a string and stored it in temp, which is O of n. Okay. And here, we are creating an LPS array of size n, which is O of n plus n, because the n is string dot size, which is s plus s, right? So, the overall space complexity is O of 2n, which can be approximated to O of n. If we take this s length as n and this string length as m, the overall time complexity will be O of n plus m and the space will be also O of n plus n. But I have approximated it and have written O of n and O of n. Simple. So I hope you guys like this video. If you guys really did, then please like, share and subscribe to my channel. It will really motivate me to bring more such content. If you have any queries, please comment it down. I'll try to respond to it as quickly as possible. And if you have any feedback for my teaching, please comment it down too so that I can improve on that. So see you guys in tomorrow's video solving any other coding problem. Till then, stay safe, stay happy, and peace.